Lesson 3.4, Polygon, Angle, Sum Theorems. A polygon is a closed plane figure with at least 3 sides that are segments. The sides intersect only at their endpoints. And no adjacent sides are collinear. Example number 1 has 3 polygons in the picture to the right. Name each polygon, its sides, and its angles. So our first polygon to the right is a triangle. And it's triangle A, B, E. Its sides are segment AB, segment AE, and segment BE. And its angles are angle A, angle B, and angle E. Okay? Our second polygon to the right is a quadrilateral. So that's quadrilateral B, C, D, E. Okay, so there's our quadrilateral. The sides of our quadrilateral are BC, CD, DE, and BE. The angles of our quadrilateral are angle B, angle C, angle D, and angle E. Lastly, we have pentagon A, B, C, D, E. So that's a pentagon. And it's pentagon A, B, C, D, E. The sides of that are segment AB, segment DC, segment CD, segment DE, and segment AE. And the angles of my pentagon are angle A, angle B, angle C, angle D, and angle E. Okay? You can classify polygons by the number of sides it has. A triangle has 3 sides, quadrilateral 4 sides, pentagon 5, hexagon 6. A 7-sided polygon is called a heptagon. Octagon, nonagon, decagon, dodecagon. And if it has more sides than that, like a 22-sided figure would be called a 22gon. Okay? All right, a convex polygon versus a concave polygon. A convex polygon has no diagonals with points outside the polygon. So, no diagonals. With points outside the polygon. So that means we have to draw diagonals. So let's draw some diagonals. I'm going to start at one of the vertices, and I'm going to join every vertex. This is already joined right here. This is a line. But I'm going to go from each vertice to a new, so right here, and right here. So I have connected I've drawn a diagonal from each vertice to the next, and none of the diagonals are outside of the polygon. A concave polygon has at least one diagonal with points outside the polygon. So let's connect these diagonals, okay? So, oh, look what happens when I start trying to connect these. See how there are points on this diagonal? You know, these imaginary points right here on this diagonal, they are outside of the polygon. So if I had to name these two polygons, the first one would be convex, and this is called a convex pentagon. And this one is called a concave. 1, 2, 3, 4, 5, 6, 7. Concave heptagon. Okay? So next I'm going to classify each polygon by its sides and identify as convex or concave. So exactly like I did before, the first thing I'm going to do is count the number of sides. 1, 2, 3, 4, 5, 6. A six-sided polygon is called a hexagon. And if I were to draw all of the diagonals, I see that the points on the lines of the diagonals are all within inside my polygon. So this is actually a convex. This is actually a convex hexagon. This next shape, 1, 2, 3, 4, 5, 6, 7, 8. An 8-sided figure is called an octagon. And when I start connecting the diagonals, I see, oh, the points to this diagonal lie outside, so this is a concave. The way that I remember it is if the points lie on the outside, that means that the side has caved in. It is caved in. That's how I remember concave. Okay? All right. The Polygon angle sum theorem says that the sum of the measures of the angles of an n-gon is n minus 2 times 180, where n is the number of sides. Okay? The Polygon exterior angle sum theorem says the sum of the measures of the exterior angle of a polygon is 360. All right, so we're going to find the missing angle measures. Find the missing angle measures. So the first thing that I'm going to do is count the number of sides. 1, 2, 3, 4, 5. So in this case, n equals 5. And I'm going to use the formula n minus 2 times 180. I'm going to substitute in my sides, so 5 minus 2 times 180, 3 times 180 equals 540. That means that the sum of all of the measures of the interior angles of this polygon have to add up to 540. So I'm going to write an equation. 117 plus 100 plus x plus 115 plus 105, and that all has to equal 540. All right, so I'm going to get out my handy dandy calculator, and I'm going to add them up. So I have 217 plus 220. So 437 plus x equals 540. I'm going to subtract 437 from both sides. So x equals 103. Okay? So the measure of this angle is 103. All right, let's look at our second example. 1, 2, 3, 4, 5, 6. So n equals 6. So n minus 2 is 4, because 6 minus 2 is 4. 4 times 180 is 720. So the sum of these interior angles must equal 720. So 720 equals 140 plus 151 plus 62 plus 135 plus n plus 6 plus n. All right? So again, I'm going to solve 140 plus 151 plus 62 plus 135 plus 6. So 720 equals 494 plus 2n. I'm going to subtract 720 minus 494. So 226 equals 2n. I'm going to divide both sides by 2. So n equals 113. So this angle right here is 113. This angle right here is 119. Okay? All right. Now I need to find the measure of an interior angle and an exterior angle of a regular polygon. So a dodecagon. We said that a dodecagon has 10 sides. So 8 times 180, that's n minus 2. So 8 times 180 equals 1,440. So the interior angles have to be 1,140 for the sum. And there are 10 sides, so I'm going to divide that by 10. So the interior angles are 144 degrees. 144 degrees. The exterior angle, if you were to think about a polygon, the exterior angle measure and the exterior angle when you extend the side have to equal 180. So each exterior angle has to be 36 because 144 plus 36 equals 180. Let's see, does that make sense? 36 times, there are 10 outside angles equals 360, and the exterior angle, the Polygon exterior angle theorem said, oh, the exterior angles of a polygon have to be sum up to 360. So that does make sense. So my exterior angle is 360, and my interior angle is 144. What about 100gon? Well, 100gon, that means n minus 2 is 98. 98 times 180 equals 17,640. I need to divide that by 100 because I'm going to divide it by the number of sides. So each angle, interior angle, measures 176.4. So this is each interior angle. I need to remember that the sum of the interior and the exterior add up to 180. So 176.4 plus x equals 180. So 180 minus 176.4 equals 3.6. So my exterior angle is 3.6. The measure of the exterior is 3.6. Again, you can check that. 3.6 times the number of sides better equal 360. And it does. Okay? An equilateral polygon has all sides congruent. Equilateral, when we talk about equilateral, just like when we talk about an equilateral triangle, all sides are congruent. An equiangular polygon, all angles are congruent. And a regular polygon has all sides and all angles congruent. Okay? All right, your homework is page 147.